Hey y'all, this is the other formative quiz that I had written in. So let's call this formative force quiz B. Okay, so let's look at this first picture here. This guy's standing on a box on the floor. Okay, as it says, draw the free body diagram for the person. Now the person is the object. So he's on the box, so I'm not thinking of the box. The weight of the box is irrelevant. So I'm looking at him up there. So there's the weight of the person. And that would be the mass of the person times G. I don't really have to do that now, but I'll do it anyway. So he's 65 kilograms. So weight is mg. So that's 650 newtons. Normal force is acting on his feet. The crate is pushing up against him with an equal force as his weight. So that would be 650 newtons as well. If it was going up in the elevator at accelerating up or down vertically, then normal force would be greater or less than his weight. Okay, just remind you, normal force is also called the scale reading if he was on a scale. Okay, part 2. Number 2, draw the free body diagram for the crate. Okay, so here's the crate. Just do a point. You're just supposed to do a point, right? So there's the crate. Now, the weight of the crate. Okay, there's the weight of the crate. I'll say WC. So that'd be 35 times mg. 35 is the mass times acceleration of gravity is 350 newtons. But pushing down on the crate is the weight of the man, which is 650 newtons. Weight of the guy, weight of the person, and that's 650 newtons that we did in number 2. The normal force, the floor pushing against the crate, okay, right here, the floor pushing against the crate, that would be bigger than the weight of the crate because the guy's on it, on top of it. So this would be 650 plus 350, looks like it's 1,000 newtons. Okay? Determine the size of the normal force that the floor exerts on the crate. Okay, we just did that. It's 1,000 newtons. Okay, number 4. Determine the size of the normal force that the crate exerts on the person. We did that up there in we did that in the very first problem, very first question. So that's 650 newtons. You can see it. You can see it right there. Okay, let's do number 5. Okay, this lady's in an elevator. It's accelerating upward. Okay, so let's just draw it. She's in an elevator. I have her sitting down. And it's accelerating upward. So for the lady, we're looking, the upward force is normal force. That's going to have to be bigger than the downward force, which is the weight of the lady. So you would draw an arrow that's pointing up. Well, a free body diagram would simply be there's the lady, there's her weight, but there's her normal force. normal force should be bigger than the weight because the acceleration is upward. The acceleration is upward. The net force is upward. And therefore, the force pointing up has to be bigger than the force pointing down. Okay, so this would be the picture, free body diagram of the lady. Hopefully you can see that the weight is less. What net force does she experience when the elevator accelerates upward at 1.5? Okay, that's the acceleration. Okay. Do I have the mass of the woman? No. Oh yeah, right up here I do. So, using that free body diagram, let's draw it over here again. Her weight is mg. That equals 50 times 10, so 500. And n is pointing up. And so the unbalanced force, or the net force, is the bigger one minus the smaller one. So the bigger one has to be n because it's accelerating upward. The acceleration is upward. So n, the arrow pointing up, has to be bigger than the arrow pointing down. So bigger one minus the smaller one is the net force. I also know net force is by Newton's second law of motion. The mass times the acceleration. Okay, the mass is, again, 50. The lady's mass, the acceleration is 1.5. That equals, oh wait, that's my answer. I'm going ahead and solving some other things, which will probably be coming up. So the net force is equal to mass times A, which is 50 times 1 is 50, 50. Okay, so that'd be 75 newtons. That's the net force. Okay, what's the normal force? In other words, she was standing on a scale. Normal force is a scale reading. Okay, in case I asked that word on the test. Okay, so I'm going to just use net force equals N minus W. We already explained that. Net force is 75. Normal force, I don't know. Solving for it. Her weight is 500 newtons. So N is equal to 575 newtons. Okay? She feels like she's being pressed down. She feels heavier. Okay, two forces act on this wagon as shown. No drag, no friction. 4 Newton force acts to the right, and 6 Newton force. What is the acceleration? Well, I can't find the acceleration unless I have net force or other things. If you want to solve it by kinematics equations, but they don't give me anything. So I'm going to use Newton's second law of motion. And from the picture, I can see that the 6 is bigger than the 4. So it's the bigger one minus the net force is the bigger one minus the smaller one. And that be to the left, because the bigger one's to the left. Okay, so what's the acceleration? So we'll put the 2 from what I just solved. The mass of the block is 2, as you can see right there. It says right there. Times acceleration, therefore equals 2 over 2 is 1 meters per second squared. Now, whoa, what did I do wrong? 6 minus 4 is 2. Okay. And that'd be 2. Okay. So I made an error. None of these choices are correct. So let's just change. The correct choice is 1 meters per second squared to the left. That's the correct choice. Meters per second squared to the left. Because, yeah. Okay. I'll correct that on the quiz. So when you take it, it'll show up. Okay? And that'll be, why is it to the left? Because the net force is to the left. The net force is to the left. Whatever direction the net force is, that's the same direction as the acceleration the net force causes. Okay. So we have the same situation, but we have, what's happening? Sorry. One wheel set is locked, causing friction between wheels and floor. So, well, it would be moving to the left because 6 newtons is bigger than 4 newtons on the other side. So, the cart's moving to the left. Okay, that's not a vector. I mean, that is a vector, but that's not a force vector. That velocity is just showing that it's moving to the left. Okay, the acceleration is given. What is the friction between wheels and floor? Okay, so draw a free body diagram first. Okay, you got your normal force. I don't really care about that because it's going to balance out with the weight. You got 6 newtons that way. You got 4 newtons that way. And so, what I say? What is the friction? Well, the friction, if it's moving to the left, the friction has to be to the right. So I'll just call that little f right there. The other arrow pointing to the right is the applied force, the 4 Newton applied force. Okay, so the net force is equal to the 2 arrows pointing to the right. Well, so the cart's acceleration is 0.25 meters per second squared. So we can find the net force acting on the cart by taking the mass of the cart, which is 2 times 0.25, the acceleration. So 2 times 1/4 is 1/2. So 0.5 newtons. Okay, that's the net force. I'm not asking for the net force. I'm asking for the friction. So let's look at our diagram. The net force is equal to the bigger arrow, which I'm assuming is 6, minus the sum of the arrows pointing to the right. Okay, so 0.5, we found what the net force is right there. 0.5 is equal to 6 minus f minus 4. So 0.5 equals 6 minus 4 is 2 minus f. So f, add f to both sides, then subtract 0.5 from both sides. Okay, so here, let's just do all the way. Negative 5 equals 0.5 minus 2. 0.5 minus 2 is negative 1.70. Wait, 1.5. 2 minus, yeah. So 0.5 minus 2 is negative 1.5 equals negative f. So F equals 1.5 newtons, pointing to the right. So it'd be that choice. That was a good problem. Is that it? Not bad, not bad. Okay, so that's a good summary.